In this video, I'll explain the delta epsilon definition of limits. Now, delta and epsilon are two Greek letters. This is delta and this is epsilon. These two letters I'm gonna use in the delta definition limits. Now, if the limit of a function exists, then the basic way to write it is limit f of x when x is approaching to a is equal to L. Now, how do we write it in delta epsilon definition? For any epsilon greater than 0, there must exist delta which is greater than 0 such that magnitude of f of x minus L is less than epsilon for each magnitude of x minus a is less than delta and is also greater than 0. This is how we write delta epsilon definition of limits. Now, what does it mean? For that, first I'll explain this inequality. It says magnitude of x minus a is greater than 0 and is less than delta. Now let's see this part first. It says that magnitude of x minus a is greater than 0. Now why is it greater than 0? Now we see that in limit when x is approaching to a, x is approaching to a from both the sides. If this is a point a, if x is going to a from the left side and from the right side, but x is never gonna reach the point a. So here x will never be equal to a. That means this difference will never be equal to 0. So that's why the magnitude of x minus a is greater than 0. Now let's see the other part. This part, which is magnitude of x minus a is less than delta. Now, how can I write this inequality? Minus delta is less than x minus a is less than delta. Now, if I add a in each term, then it becomes a minus delta is less than x is less than a plus delta. Exactly like this, I'll rewrite this inequality. Minus epsilon is less than f of x minus L is less than epsilon. If I add L to each term, it becomes L minus epsilon is less than f of x is less than L plus epsilon. Now I could write this inequality as this and this inequality as this. Now let's see how does it look like on the graph. This is x-axis, y-axis, and if this is the point A, this is the point L, and let's say this is the graph of some function f of x. Now because x is never gonna be equal to a, so I did not define this function at the point a. Now here we have a minus delta is less than x is less than a plus delta. Now what is a minus delta? Because delta is positive, so a minus delta will be less than a. That means a minus delta will be here somewhere. A minus delta, and like that a plus delta will be more than a. So a plus delta will be here somewhere. That means x lies between these 2 points. Then on the graph, the range of x is between this point and this point, excluding a, because x is never equal to a. Exactly like that, if here is somewhere L minus epsilon and here is somewhere L plus epsilon, then f of x lies between these 2 points. Now what does this definition exactly mean? It says for any epsilon greater than 0, if there is an epsilon which is greater than 0 and for which this inequality holds, that means this inequality holds. And what does this mean? That f of x lies between these 2 points. So it says for any epsilon greater than 0, if f of x lies between these 2 points, this inequality means that f of x lies between this range. Then there must exist a point delta for which x must lie between these 2 points, excluding a. There is a point delta for which the range of x is a minus delta and a plus delta. So this is the delta epsilon definition of limits. I'll do an example using delta epsilon definition. To use this definition in question, what we're going to do is we are going to take any epsilon for which this inequality will hold. Then we must be able to find the point delta which is greater than 0, and for this delta this inequality must hold. Now because we are going to take any epsilon, so the value of delta will depend on this epsilon. So delta depends on epsilon. So what we're going to do, we'll take this part and we'll reach this part. For any given epsilon, if this inequality holds, then this inequality must hold. And we should be able to find one delta which depends on epsilon. Now I'm going to do this example which says prove limit x approaches to 4, 4x minus 15 is equal to 1 using the delta epsilon definition. I'll write the definition quickly. For any epsilon greater than 0, if f of x minus L is less than epsilon, then there must exist the point delta which is greater than 0 and it depends on epsilon. Then x minus a should be less than delta and greater than 0. If we take this, then we must find a point delta for which this inequality is true. So let's take any given epsilon greater than 0, f of x minus L magnitude. So f of x is 4x minus 15 minus L minus 1. If this is less than epsilon, then we must be able to find something like that. So this becomes 4x minus 16 is less than epsilon. I can write it as x minus 4 less than epsilon. and this becomes 4 into x minus 4 magnitude less than epsilon. And now if I divide this inequality by positive 4, it becomes x minus 4 magnitude is less than epsilon. So what can we write? Magnitude of x minus 4 is greater than 0 and is less than epsilon by 4, which is equal to delta. Now because epsilon is greater than 0, so epsilon by 4 is also greater than 0. That means this delta is greater than 0. Now, according to the definition, for any given epsilon, this is true only if we are able to find this part. So that means by delta epsilon definition, limit x approaches to 4, 4x minus 15 is equal to 1.